Yeah.
Simpsons characters. That's right. So it's got like
Well, it's not like a Kaggle competition. Kaggle just lets you put up data sets too.
And so somebody had annotated like 10,000 screenshots from the Simpsons.
Okay,
like what
okay.
character is in there. And so it's like Bart Simpson, you know, all the other characters. I'm not like a huge Simpsons fan. I've seen a few episodes, but I guess Matt is a huge fan. So he was really excited about it. So I showed him how it would work in Sconce. He seemed excited. And we'll have one. I'll get the nerd out. Possibly by Sconce a little bit more. Yeah, he was supposed to come last week, but then at the last minute he canceled. Keith Chester?
Yeah. He's the one who's been doing the
Yeah, the body.
But the body thing,
adjustment.
okay. Yeah.
I think he's looking for it.
Yeah, he's trying to go to the West Coast.
Oh, okay. There's a new Kaggle competition by Google on multi-box identification. And that's what I'm going through on Fast AI, their multi-box thing. It's getting very hairy. I mean, the amount of the loss functions and stuff. I mean, it's easy to identify a class, easy to identify two classes and stuff. Now, the thing is easy to put a one bounding box across one class. Now putting multiple bounding boxes across multiple classes, that becomes, I mean, the amount of, and in fact, in that deep learning course too, he says that the second video is one of the most repeated. I mean, people watch it 2 or 3 times before they understand what's going on. Because the architecture is pretty simple. It's just a loss function. You got to deal with the way you have to put it together.
Oh, it's trying to find relationships between the objects.
This is a little bit more advanced than that. Not just putting the bounding boxes, I think.
Yeah, but it's like woman playing guitar and beer on table. So it's like
Okay.
finding the objects and the relationship.
Relationship between them, yeah.
Yeah, I gotta.
Because these bounding boxes is what they are selling in DeepLearning. That's all they're doing. I mean, they're putting one of those algorithms behind, and it can, through a video, it will show you what the bounding boxes are, and that's what the DeepLearning is doing. At least one of the models. I mean, here this goes beyond that. So, which means you got to build something into the model that can identify the relationship, how close they are, or something like that. And
So you've been working on this?
no. I'm working on the fast AI just to put these bounding boxes thing.
Oh, okay.
I just saw this come through last week and said, wow, okay. This bounding boxes is getting even more complicated. They want to start putting these things more information and stuff. So I'm sure Jeremy or Fast AI Group will compete in that. So you guys have played around with that data set. So I mean, basically used all the usual techniques and stuff and on the data set and
On the Dollar Street data set?
Yeah. And how much did you come close? I mean, did you do a class? I mean, on the salary, not the salary. I mean, the income. Did you do
We built a
regressor for that? I mean,
Yep.
Did you regress it as a continuous variable or okay?
Yeah, and it does okay in log scale.
Yeah.
Which maybe it can't really do any better because who can tell the difference between someone who makes 2,000 and 10,000 a month, like based on a single image.
Yeah.
But there's really only 220 like families.
Yeah.
And so
Yeah.
there's just not that many, even if consider all the different kinds of photos they have. So I don't know,
Even after 220, even after considering all the different things like the roads, the doors.
Well, we didn't try to do any like combinations of photos.
Okay.
But that was one idea that people had was instead of just doing a 3-channel image for RGB, you could do a 6-channel image and then always have like, you know, a picture of a house followed by a picture of, you know, beds.
Oh, okay.
Or whatever. And then
okay.
like
so there'll always be I mean,
then you
6-channel,
always 6-channel or 9 or 12 or whatever.
Yeah.
Like,
yeah.
And you could stack all the photos in there.
Yeah.
As just different channels, and you could.
Yeah.
Maybe we could do better that way. There's lots of things that we have tried, but we didn't get it very far into it.
Okay.
The first week, everybody downloaded
the data set
into Google Colab and stuff.
Yeah.
But I don't think anybody had the appetite to wait another 30 minutes for the download again. I didn't like zip it up or anything, so it was like downloading straight, like image by image from the Dollar Tree.
Okay.
So like I could have just put it up on a Google Drive.
Google Drive or something, you shared it, yeah. Okay. Okay.
I just wrote scripts to pull it down and then shared those scripts, and everybody pulled it down separately.
Pulled it down. Okay. Okay. Along with the income and all that stuff.
Yeah.
The JavaScript thing that you wrote.
Yeah. Well, no. Yeah, I shared the metadata files on the GitHub repo. And in the metadata files, they have the links to the original images. So everybody just downloaded all the original images.
Okay. Okay.
I did hear back from the Dollar Street people, and they said, "Sorry, we still don't have any way to download everything."
Okay.
So, like, they get back to you after like 2 or 3 weeks, but they don't really say anything useful. So.
Yeah.
We looked a little bit at the heat maps, but because we weren't getting a very strong regressor, I don't think the heat maps were very useful. Like,
for some of them, it looked like it might have been picking up on something.
Yeah, I mean, it kind of like matched.
Aligned with certain parts of the image.
Yeah, but it wasn't clear that, what it was doing.
The heat map.
Yeah, so the idea was that we would build these fully convolutional networks. And then the last convolution is just a single pixel, single channel.
Okay.
That's the regression value. But then if you go back one layer, it was a 7x7 single channel image. And then you can just overlay that over the top of the original image and see what parts of the image.
7x7,
what parts of the image are giving positive value, what parts are giving negative value to the regression. Okay. But the regression wasn't particularly good. And so neither was
it's like what he tries to shine like on a cat. He tries to do a heat map on that and tries to see where did it find the cat.
Exactly.
And stuff. So Yep.
We did exactly.
Yeah. So, okay. I mean, DQ mentioned you wanted to go through the recurrent neural networks a bit.
I mean, if you're interested, that's just for project I'm working on.
Yeah.
I actually talked to David earlier today, and we had a little bit of discussion.
Yeah.
So initially, based on research I was doing, it seemed like RNNs with LSTM would be best for time series data. But then when I was going through some more deep digging, they were talking about ARIMA and Jeremy uses entity embeddings and something different. So
you can. I mean, you don't have to use recurrent for time series. I mean, you can use the whatever embeddings model that Jeremy uses. Jeremy uses from the Rossmann data set that we went through.
Right.
So that'll be your best bet to start off with. I mean, because here, like they're trying to. I mean, the language model, they're trying to say, okay, what is the next character that comes out and stuff. It is like a time, but it's not the same as the time series. But they want to at least memorize what had come before and before that and stuff. I mean, that's why they're trying to use a recurrent network, trying to memorize what came before, and then can I predict the next one? But on these time series things, as Jeremy says, I mean, yeah, instead of using all this arima and taking out the seasonality and all that stuff, can you just say, okay, what day is that, and what week is that, and what month is that, and what year is that, so it can figure out what the stuff need to be. I mean, instead of you trying to pull a seasonality and then they use a lowest model and then they use a arima model after that, and which is much more painful and stuff compared to what he does with these. I mean, the data preparation, yeah, it is intense on the data preparation, but you can bring in other data into it easily. Like the Google Trends data, he brings in the weather data, he brings in, there's so much other data that you need to bring in a time series to kind of get what is correlated to what.
I was trying to see what models give the best results. It's kind of hard based on what I'm looking at. Everybody's got different opinions of this. I may have to just pick one and then try it out.
I mean, you have to put a baseline. Okay, you start with the normal multilinear regression model and you get a baseline out of that. And, I mean, the time series, it depends on what you're looking for in the time, what you're trying to predict on the time series too. Because things are time series, but there are things which are more constant across in a process in an industry. Yeah, there is timestamps and stuff, but that doesn't influence this. It's just a independent variable situation. I mean, in your time series, what are you trying to predict, and are you trying to forecast something?
This is like,
and you do.
They have like date, time, and then like order volume or something. So it's like one. They don't want to. I don't need to predict like years ahead. It's just maybe next hour or the next day. So as long as your model is very accurate on that. That's what they're looking for. It doesn't have to be.
So I mean, usually the baseline you start off with, if I want to predict the next day, today's data is next day's prediction. You can start with that, okay, and then see what the error is. Okay, that kind of establishes. That's the most simple way. Hey, tomorrow is what is today. Yeah, it may not be I mean, then you try to just start, but you have to establish a baseline. Okay, what is the most simple way to predict something that I've got? Well, today's data, I'm going to predict that's going to happen tomorrow. I don't know that, or a week from now, whatever happened this week is going to happen next week. That kind of establishes your baseline. Then you start improving your model and say, okay, can I predict better than that?
That's kind of what I recommend. Pick the simplest method and then improve on that.
Improve on that.
You want hour by hour or?
Hour or by day ahead, I guess, but it doesn't have to be like long term. So, I mean, I kind of want to do RNAs because I'm interested in them, but I also need to make sure it's something it can be done in a certain amount of time. That's not too complicated. They start out with something simple.
I mean, in the RNNs is where he starts using the torch text and stuff. I mean, he has moved away from torch text, but you can use torch text to do some of these things, and it is simple.
In RNNs for time series, right?
No. He doesn't do that for this thing. But if you look through his,
have you guys heard of this guy named? He does machine learning master. He has a bunch of ebooks. I don't know if they're very good. They're in Keras, but he does a lot on time series stuff.
Okay.
What is it? It's machine learning mastery. I mean, I don't know if he's just trying to promote his ebooks, but they're like $37 each. But Yeah, it's. I don't know. I'm might take it.
Does he work somewhere?
It says he has a PhD in AI. This box has come up a lot in search for. Jason Brown. Says he works on machine learning systems for defense startups and severe weather forecasting.
Art can be good.
Yeah. Sometimes these guys are just trying to sell their books, but it might be. Other things I gotta decide what language I want to take into production. I mean, like I would prefer like PyTorch or Keras, and like you said, I can use Onyx to put that in cafe and get that in production. But definitely, yeah, probably don't want to do that. Not that.
Aren't they on the verge of
Yeah,
releasing?
1.0 is supposed to
Yeah, like
combine
now-ish. Right?
Cafe
Yeah.
and PyTorch.
By the way, the
Yeah.
reason they are using MATLAB is, did I tell you? Or no?
I think they had a person there that just
Yeah,
did
It
it.
left and you said, yeah.
That's why they.
Yeah.
That.
Yeah.
That's a pain. If only one person has access, we gotta get the license.
What machine did she use? Do they have a machine for you to work on?
I don't even have a laptop. Is this being recorded? So we shouldn't. Yeah, I mean, yeah, I'll be getting that stuff. If not, I was thinking, doesn't Jeremy recommend building your own GPU and all of that?
Yeah.
For long term, if you want to be.
Oh, yeah. Yeah.
Do you guys think that's worth it, or? I mean, long term.
Yeah, but you
wanna be-
can't work on their data
Yeah.
on your machine.
On your machine, you can't, yeah, it has to be a company machine, so.
Even separately, if you're trying to play around on your own.
Oh, yeah. Oh, yeah.
Long-term.
Oh, yeah, long-term thing, you want to build your own machine, and I don't know if any GPUs are on sale on Prime Day.
That's Friday. But Paperspace is cheap enough too. Just
Yeah.
Which conference room are we in?
I can't read backwards.
do we need to let someone in?
Yeah, somebody's asking which conference room we are in. The Honeyberry Dripper. The Honey Dripper conference room. So, I mean, have you gone through Jeremy's RNN, or I mean,
Yeah,
I have gone through it and I've
Yeah,
done some work on it. And,
Yeah,
I mean, do you understand what the RNN, how it works and stuff?
Yeah, I mean, I went
Okay.
through this, but it's been so many different courses.
I mean, when you went through it, I mean, did you write it off on
Yeah,
your
I mean,
own and stuff? Rather than if you just see his, then it's of no, yeah, it's
I
like,
took notes and then
yeah.
but I didn't get a chance. I wanted to go back, but I
Yeah.
just haven't had time to
yeah,
really look through it again. So I couldn't remember exactly what he was using. But yeah,
okay. I mean, he explains, I mean, this is main thing, he explains what an RNN does,
right,
this chart-3 model.
right.
And I mean, he's trying to basically, here's a text, which is any text. But he's got niches. Is this like a German guy? Nietzsche? Philosopher, Nietzsche.
Yeah.
Yeah. So he's taken a text which has what, 600,000 words in it,
Right.
600,000 characters, I think, 600,000 characters in it. So it's it's not a huge amount of text. And then he says he's just creating creating a character list out of that. I mean, he's just saying sort of list of that set of text, so he knows what characters are there. So he comes up with these 86 characters. That's a vocabulary size. So you got to do the vocabulary size, and after that, he's just doing the indices of the character and the indices to character thing. I mean, mapping those. I mean, once he has that, I mean, he knows. I mean, he's just converted characters into numbers. That's all he does. I mean, that's how he's not the numbers in the sense, yeah, wherever it is. I mean, he's given A means capital A will be a number 40 or whatever, or P. I think capital P is 40 and R is 42 and 29, but these are unique numbers, which is the vocabulary size is your 86 vocabulary. So there'll be 86 different numbers that can represent the whole text. And then what he does is, I want to, basically his thing is, if I give the first 3 words, I want to predict the 4th word, 4th character. Because I looked at his language model, it gets a little bit complicated, but he covers that in his deep learning course too, which is where he gets into the details of that. But the character model is where he explains the RNN pretty from the basics. I mean, he's saying, well, I just need the first character. So it'll be the first character jump 3 or jump 1, 2, 3, 4th, and then jump, then get the next character, and then the next character, because he's saying IDX of I, range of, well, he's not even jumping there, len of that. All he's saying is the jump. Yeah, the last argument is a jump, the CS, yeah, that's where the range is jumping. So he's saying 3 jump, and then he's saying the next character and the 3rd character and the 4th character. And he's now going to predict the 4th character. Y is going to be the 4th character. He's going to predict the 4th character. So he's got all these characters, and X1, X2, and X3. And I mean, the thing is, here's what he builds the model. I mean, here's what he says. What does the RNN mean? Is he's going to embed. He's going to build an embedding layer so that it can take the vocabulary size and n factors. He builds whatever he chooses a factor here. I mean, n factor 42 factors. So he says the embedding size is going to be 42. He's going to for each of the characters, and then there is a linear layer, and then the hidden. We'll get through that. I mean, here's where he gets into, if you look at this, so he has a linear layer, and then he has so that goes from 42 to n hidden of 256. And then there is a 256 to 256, another linear layer. And then the out is the 256 to the vocab sizes. It's going to predict the 86 character there, up there. So the thing about the RNN is, okay, initially he does a ReLU on the linear, on the embedding of C1, and he uses the same thing on C2 and C3. I mean, the first character, second character, and third character, he's using the same linear layer, the LIN, and the ReLU on the embedding. Embedding is obviously has to be the same, but he uses the same linear layer. He's getting there. And then here's where the hidden layer is, where he's saying, okay, I mean, once he's got this many hidden layers, and then he starts off this tan H of, I mean, he could have done a ReLU, or he says, I mean, tan H gives him the ReLU cuts it off, but the tan H doesn't cut it off. It comes in like a sigmoid, but it is different from a sigmoid. So he still gets the -1 to +1 range on a tan H. And then the L hidden of H plus IN1. And then so he's starting with the zeros. He's starting with zeros. So it's going to do is pass the first character through a linear layer. So you're going to get 256 going into a 256 out. But the next one is where he's going to add this H plus the IN2 and send it across the same thing again. That's what he says is the RNN is, I'm going to send it back through the same, well, what do you call this? It's a loop, but he's sending it through the same, the layer, the same layer again. So, which is what he explains in his video is, here's what it happens is I'm going to send it across. I mean, here's what comes out here. Comes out, and then he says IN1 is your first character. And then he sends this, which is IN2. He adds these two and sends it across, but this is the same as this. And then he sends this, IN3, through the same one. He adds those two and sends it across, and then you get the output here. I mean, you could have represented it as this. I would think, I mean, it's going back. Well, I don't know how you, this hidden thing keeps coming back again. See? Because you're getting a input, it goes in, it comes out, then it adds it up to the next input and goes in again. That's what is your recurrent network doing. And so that there is a memory, it creates it's taking the input of this character, and this character. So there is some memory that's built in based on what is the first character, the second character, and the third character. I mean, that's a basic idea of the RNN, where he's building. Okay, now and then when you do a gradient descent, it's just doing a gradient descent on this one thing. I mean, there is no three different layers. It's just one layer. He's just sending this over and over again into that same layer with just adding whatever comes out from that layer from the previous step with the new input, and you send it across again.
What is capital V here?
Capital V.
It's in,
Where?
in the middle
Oh,
of
this is the
word.
variable. That's part of torch, PyTorch.
Yeah.
It just describes the variable.
You used to have to declare them as variables.
No, you don't have to do them as a variable. You don't have to. You just say V, which also means that it'll also do a gradient descent on it. That is, it'll say the gradient descent, the required grad is true if you do a variable.
Yeah. Variables are being deprecated though.
Oh, they are? Okay. What is?
There's just tensors now.
Oh, okay.
With requires grad equals true. That's all it is.
Oh, okay. Yeah. Okay. So it'll be just declaring this. You just don't do a V. You have to declare it as a tensor with a grad equal to true then. Okay. Yeah. Okay. I mean, V is default grad equal to true. That's why we used to use V, because there's something called a parameter or V. The parameter is different. Okay. Those are the weights and stuff. The V itself, there is something else on the, other than a V where the default grad equal to false. I thought there is something else like a V, almost similar, but it's just the grad equal to false there. But yeah, that's all he's doing is he's doing a tan H on that. He's saying instead of a ReLU, he just wants to tan H. He's saying, I mean, the tan H, he says, it doesn't go through the zero axis, but it goes through something like this. I think the sigmoid goes through like this, the zero axis, but the tan H goes through something like this. But it's still kind of that the large values become, I mean, you're the plus one.
Well, sigmoid goes from 0 to
and then
1.
minus 1.
Tan H goes to minus 1 to 1.
Oh, sigmoid just goes from 0 to
0 is 0.
Huh?
Tan H of 0 is
0. Oh, it does go through 0?
But it goes all the way to minus 1 instead of just to 0.
0. But then the sigmoid just goes to 0?
Yeah.
So it just goes like this?
Well, no, like sigmoid of 0 is a half.
Oh, okay. Oh, it goes like this, half. I mean, this is the 1 and this is it actually goes to 0 on this side?
Well, asymptotically.
Yeah. Asymptotically, it goes to 0.
Yeah.
So it only goes from 0 to 1.
Whereas tan H
Sigma
goes
tan is
minus
goes from 0, 1 to -1. So. Oh yeah. The sigmoid is just okay. Yeah, it's like softmax does your probability, but then the sigmoid sigmoid doesn't do a probability because it's not doing the sum division thing, and yeah, it just gives
a single one.
yeah. So it just makes anything big to close to 1, and anything close to 0 is 0, and it just goes from 0 to 1 to 0 on the sigmoid. And I mean, he doesn't say why he says tan H is a good thing. I mean, people have used tan H before, and you probably don't want to cut it at 0 by using sigmoid. You want to have a 0 to -1 there. And he says, I don't want to cut it through a ReLU on this, and so he uses a tan H.
And there's some reason that they don't use values for doing
The-
recurrent neural networks.
Isn't it the exploding gradient?
Or the vanishing gradient, I assume? Yeah,
Oh, okay.
because it's not actually differentiable for negative values. And so the derivative is exactly 0. And so if you're going through multiple times, each time that you got to anything negative, you would just like all your units would drop out kind of.
Okay.
I don't know all the details.
That will be,
but-
yeah. I suppose. And then he just at the end you just do a softmax log softmax of the L out of the hidden layer. The hidden is just okay. The final output that comes out, you're just doing a log softmax of that. And obviously, I mean, this is just to at least introduce you to the basics of what happens, because we use the LSTM and then the GRU, which have the gates and which have some hyperparameters into it to make the memory happen more efficient. Then this is just the basics of how an RNN works. I mean, this is what an RNN would do if you just, and he says this is what an RNN does in PyTorch. I mean, if you use an RNN layer, and with how many ever you describe, I mean, this is what it'll do. This is what internally it does.
This is back propagation through time of 3.
3, yeah, to time of 3. And yeah, and then he calculates the log, the negative log loss on that. After the log softmax, it's interesting. He doesn't use a softmax. He uses a log softmax and then an LLL loss.
That's a PyTorch ism or whatever. Like the log softmax is more numerically stable.
Stable than the softmax. Okay.
Yeah, and so then the NLL loss is really just a sum. Like it doesn't actually do any. It just sums.
Oh, okay. Yeah. If you do a log softmax. Okay, the NLL.
Well, I mean, it doesn't know what you've done before.
Oh, okay.
NLL loss is just poorly named.
Oh. It's not even a log.
You've already log scaled everything. It just does a sum.
Okay.
Yeah.
Oh. So the negative, it's not even doing a negative log of.
I guess it does the negative part of the log.
Negative part of the log, but it's not doing any log, or it's already
assumed. No, that was done in your log softmax.
Okay.
Yeah. No, it's maximally confusing for no reason.
No reason then. They should have just have said, okay, all it does is negative of the sum or something then if it's not doing anything.
That's what the documentation says.
Okay.
Is there a recommendation or limit on how many you can go back? Does he say anything like that?
Well, it becomes more, the more you go back, he says, what is it? It becomes computationally more, difficult.
So it's a performance.
Performance.
Well, there's 2 reasons. You have to keep the computational graph in memory, so you're going to be using up more of your GPU memory.
Yeah.
Because each time through, it has to save those so that it can then back propagate all of your gradients. But then in addition, your network is getting actually deeper.
Yeah.
And so
more
at some point, you'll have the vanishing / exploding gradient problem. And they have it worse in NLL or in recurrent neural networks than, because there's no shortcut connections like there are in the ResNets and the other modern
Yeah,
convolutional networks.
because even if that, yeah, because the previous layer comes back and connects and
Skip
there's
connections
skip
or whatever.
connections and stuff. Yeah.
So there's a real problem of stability.
Don't the grooves fix that though?
The grooves,
So like the
The GRUs, yeah, the gated recurrent units.
a groove,
Yeah.
groove. I thought you said grooves. I don't know. Maybe. I think they're trying to make it so that you don't need such a long memory, but you get something equivalent to a long memory because it's computationally intractable. If you could just have a longer memory, it would be better than a groove, right? I would think. I don't know. Maybe not.
It's been too long, like I can't
Is
remember
this
the details of it.
Huh?
It's in PyTorch or
Yeah, this is in PyTorch. So he just does this as a thing without doing the batching here. Okay, so this is just a basic thing he does. Yeah, I'm just gonna separate out. I'm gonna take the text and things, and then all he does is he's just taken the 60 first 60 characters and did this. But after that is he starts building, okay, just to show, okay, what does a recurrent neural network do? And after that, he starts building this batching thing, okay, and data sets and all that stuff. You start building that.
He's resetting the hidden state every 3 characters.
Every
I
3
think
characters.
I remember him
saying that.
Changing it later to where he actually saves the hidden state in between training steps.
Between training steps.
So like here, you're defining a variable in the middle of your forward function every time from scratch, the V part.
No.
See, that's not getting saved.
Yeah, this V part, you're doing this.
But later he like saves
he saves that. V
so
on that so that the next batch he can provide that. Yes.
Then
he does that.
You have to warm up your network, right?
Yeah.
If you want to do inference or whatever, you have to be like, I have to send a few hundred characters through before I can send the next part through so that it remembers all.
Yeah.
Is this the video where you did it from scratch? Did you use the fast AI library?
No. He's just showing how RNN works. So before he gets into the fast AI library, I mean, he actually doesn't get into the fast AI library in this lesson. In fact, he shows this. I mean, this is the initial step, as you said. Then he builds a data loader and a data set for this, so that we can have that. Hey, I can have a batch of 60, 64 or whatever size stuff that I can start feeding on the whole thing. And so once he has that, so he has this now. I mean, the 67, 8, and 2 and stuff, and then the 62, and then the third character, and so. And then the char3 model, he sends it across. What is the char3 model? Yeah, you can send the batch into that model, and then you can start training, and you'll get something out. And then he defines, what is it, PyTorch. It's just defining a T there. Convert NumPy array to a.
So you start using half.
Huh?
So you start using half precision.
Yeah, half tensors and stuff.
Why?
No, he has some reason for doing that. He says Pro 32. He says go to half tensor, and he actually gets into the half tensor even more in the deep learning course too on this half tensor. I don't know what that means. I mean, instead of the floating point is how many, so he's using less than that, and somehow there's a half tensor in PyTorch, I suppose, that's already defined. And so he uses that because he says he can get it running faster or something like that. I mean, he talks about it.
Doubles your memory, right?
Yeah.
In terms of number of floats you can
store. Yeah.
And but I mean, other than that, I don't know why you would mix that up with all of this in terms of like teaching people?
Teaching, no, he's just, I just put, this is his general definition of a T, okay?
Oh.
General
okay,
definition
nice.
of a T. So he
So he's
says
not
in
doing
which
it right
half is
now.
equal to false, okay? He's not doing that here. He's not doing that here. He uses it later, as I
It's a little
said.
convenience function to
It's just a
pull things
convenience
off of
function
the
for converting an NumPy array into a PyTorch tensor. That's all he does.
I see.
The next thing he does is, I mean, he gets into a little bit, I mean, he starts using using some of the torch text stuff to build some of this data set instead of using this his own thing, because torch text also has utilities already built in where if you're given the data, it can figure out the vocabulary size, and it can build the indices from character to indices, indices to character, and all that stuff. So that you don't have to build it yourself. So he uses that torch text to do that. I mean, like numericalize is a torch text thing. It'll automatically numericalize the text into all these. I mean, it'll figure out what the vocabulary size is, and it'll numericalize the text so that you don't have to go and do that yourself. And there's a batch function and stuff. I mean, he's just describing the data set, and you'll have to go through that.
Level embeddings or
no, this is all character level.
Okay.
Character level. This character level is easier to explain than the word. I mean, he's just trying to, this is more on the RNN rather than building some language model here. So if you see these, I mean, this is where he's built his, now he's actually built, this is actually bigger. If you look at this he's got a BPTT of 8, not just 3 now, which goes in time period of eight back 8 time periods. So and the 6 and the 7, and you can, and then this is the output. Output is just a big thing. I mean, big thing comes out of it for each one of these, 8, 10 and stuff, and because you've got probably 64 of these. And then as he goes through that, I mean, the corpus length is 450 something. Basically, here is where I'm trying to see the stateful RNN. I mean, this is where he uses the RNN, which is very similar to what we saw before.
Stateful, because now it keeps the hidden layer as stateful.
Hidden layer as a stateful thing. So he uses the RNN, which is same as what he has defined before, just to say, I mean, that's what PyTorch actually does. And so he's saying, hey, vocabulary size is this, RNN is n factorial n hidden, and then the allowed is just n hidden to vocabulary size. And then the RNN, he does this, the output. What does he do? The repackage war of H to detach time from their history. This is where he does something. Every time he goes through this, he detaches the history. He says something, I mean, otherwise it'll explode in memory, he says. And he does a detach on it.
Mm-hmm. That's
It's
PyTorch, as you're going, it keeps building onto the computational graph.
Okay.
Until you either throw away the variable or you detach it from the graph.
Okay.
And so each time that he goes through a forward pass in the training loop, he wants to have the values from the previous hidden state, but not the history of how it obtained those values from the very beginning of time.
Okay. Okay. because this one, self of E of CS. So yeah, embedding of the CS, the RNN, and then the CS is going to be, when he puts this in the forward network, CS is just going to be these 8. I mean, so it already knows it. I mean, it's an 64 by 8 array, or 8 by 64 array. So it'll loop through it. I mean, it loops through it, the output and H, and then at the end of that, he wants to keep the H so that he can feed it into the next loop, as you said, but he detaches it. But this one, just the self.rnm would go through this loop 8 times. Because that CS that is going to go as an input, if you see here, I mean, we're going to put that vocab size in factorial, in factor. What's the char model? I use that, the val DL. Yeah, because the train and val, I mean, this has been defined as such a way. I mean, this is your x's and this is your y. I mean, when you because it's been defined as a tuple there. It's a tensor tuple, which x and y there, and so when you read through that in the forward loop, that's what you're sending through, and so it goes through the loop 8 times, and then you're detaching at the end of the thing so that you can keep using that for the next time. I mean, that's why he's saying self.h is that, so that it'll remember it when it comes back to the next loop. And he does the same thing. I mean, he's just doing the softmax of L output of this dim, and then he's just then flattening this out for the vocab size he needs, because he's using a batch here. Rather than, I mean, initially he wasn't using a batch, and he's just flattening it out for the vocab size in the batch.
I don't know if that has anything to do with the training versus validation data. It seems like if he were to pass in validation data, that would taint his H variable, because now his H is in some ways, his hidden state is somehow seen the validation data, and then it would be used in the next loop to train for real.
Why would it train? I mean, with the validation, it doesn't calculate any gradient descent. I mean, in the validation phase, you don't do a gradient descent.
Yeah, I know, but he's updating it does a forward pass.
It does a forward pass. Yeah.
But it would save the hidden state when it's done. Right? And then the next forward pass, that is a training pass, would have the hidden state from the previous validation pass. Maybe he docks it and fixes it, or maybe he just doesn't do validation with this data set. I don't know.
He does. Okay. No, he does do a validation on that. I mean, because we create the seed, this is the validation set we create here. Because all he said was, and the same thing I'd also done this before I saw that, was he just cuts it off at the end, some 20-30% of the text, and he says, that's my validation text.
Yeah, it seems like you would need a separate hidden state for validation, sort of like what they do with.
So you're saying, because if he sends the validation set, the end of the validation, that self.h would be there. And then if he starts the training again, then it'll start with
batch
this.
Norm. You don't let batch norm weights get updated during a forward pass of a
validation set. Yeah.
Like that layer is smart enough to know whether you're in train mode or eval mode.
Okay.
And he needs to be careful not to save H if he's in an eval mode. Because maybe it doesn't make any difference.
Because there is a statement here when he starts off with self.h.size not equal to BS, then he says self.init BS. That's where he's making it 0. At the beginning, there is nothing there.
But he needs an if statement in there. If self.train, then save H on the self.h equals repackaged var H. That should be inside of an if self.train. Because if
If
you're not
self.train,
training,
yeah.
then you should throw away your
You
if
should-
state when you're done.
When you're done, yeah. So he needs to have another if statement or something so that he can run this self.init hidden of the thing there. The batch
Otherwise,
size
his
there.
validation numbers are suspect. Because he could be training to his validation set accidentally.
Yeah. No, I don't think he mentions that. I think, yeah, that is a good point there. I don't think I remember him mentioning that. I don't know. I mean, he's already initializing it to start off with. Then there is another initialization somewhere. H.size of one is not equal to the batch size. He's just checking in case somehow.
In case he changes the batch size.
Yeah. Or something like that. Saying, okay, I need to be, because the hidden has to become, it has to have the batch size, right? Otherwise it won't work. So he's just using that just to make sure.
Yeah, he could get rid of the thing in the initializer because.
Yeah, he does that.
Well, no, I mean, he could get rid of the line that you got your cursor on, isn't it? Hidden there?
Yeah, here?
Yeah.
Yeah, right? He could get rid of that if he's using this.
Self.h to exist, because otherwise the if statement would throw an attribute there.
Yeah. So it has to exist, and so he has to do that initialization. Otherwise, okay. Yeah. So he does. I mean, this is all this is the same thing. I mean, the same thing he does with this. I mean, he just goes into a stateful GRU after that, and he just says, "I'm going to use a GRU instead of an RNN," and he gets better results out of that. I mean, once you start using a GRU, he gets a better result, and I mean, it's almost exactly the same thing. It's no difference. He's just using the GRU there.
Oh, he even calls it an RNN.
Yeah, he even calls it an RNN, but
he only changed the one line.
One line just says GRU there, and self.rnn and self.h, and this is something he does. I don't know why he does variable of h.data.
Yeah, he doesn't use the same function again. It had a name. I don't remember the name of it.
Because self.repackage.
Instead of repackage bar, he just puts a V.
Oh, V of things. So he just
V of the data. Okay.
Data. So it still detaches itself if he does that, I suppose, because he's just describing.
Throws away the old age.
Old age
and copy the data
into the thing. So it doesn't have the graph of that age out there. So.
Yeah, it makes me think someone else wrote that part and he just used it. Because it seems schizophrenic. Like, why would you do it one way one time?
Yeah.
And a totally different way
the second time, yeah.
It's not good. I wouldn't put it past
me. You just like, yeah, maybe he had a bug and he was just like, maybe it's this, and he changed that and didn't go back and make it consistent.
Yeah, this was just my notes as I went through this, and I said, okay, he starts with the 3 characters and tries to predict the next character, and with the 4th character is Y, move 1 character and do the same thing. He says that in this thing, you're feeding the same characters multiple times to the neural net, because first time he does this, he take the 3 character and then the 4th character, and then he would move 1 character later, and then the 3 character and the 1 character. Then he says, well, I'm feeding in the same character again and again. Why should I mean, that's pretty inefficient. I don't want to do that. So what he does that is, then he says is, take the first 4 characters and make Y as a multiple output. He doesn't make Y as 1 output. He takes 4, it says he takes first 4 character, and then Y will represent 4 characters that have moved 1 sequence step. What he does is this. He says, I don't want to send, because if I am going home and stuff, I mean, initially he would have said, okay, I'm going to feed I am and then the Y will be G, and then the next one will be A, M, G, and then the O, and then the next one will be the M, M, G, O, and then the I. I mean, these are all the Y's, would have been the Y's here. So you just move, you do the same characters, 3 characters, and 3 character, and then the 4th character, the 3 character and the 4th character. But then I'm sending the same thing into the neural network. It has already seen IAM, and then I'm sending AM again. And so instead of that, he says, is I'm going to send IAM, and then I'm going to make, he says, I'm going to make, if this is there, I'm going to make the, if this is my inputs, I'm going to make the output as GOI. So that this, because I'm trying to predict from here, I'm trying to predict the, this would be the 3rd character from there, from A, this would be the thing, and then from M, this would be the 3rd character from that. So,
Did he do that, or did he just say that?
no, he did that. No, he did that. He did that. Because he says this is okay for, because you're feeding the same character multiple times. The better way is to say the first 4 characters, make Y as a multiple output. Y will represent 4 characters that has moved 1 sequence step. Then skip the 4 characters and start with the next 4 characters and do the same thing. So you're only feeding the characters once to the neural network, neural net. And then since it's a multi-output, because if you're seeing this, yeah, that's what he does. I mean, he says now I'm predicting multi-outputs rather than the Y needs to be a multi-output Y. So what he does is, this is what so he takes the output from each one of these. So he then compares it. That's what now I remember. This is an output that comes out from here. This is an output and this is an output. And he compares each of these outputs with this Y here. And he says, that's my loss function, because I'm going to say IAM. If I send the I should get G. If I'm getting, if there is no loss, if I send I should get G. And if I send in the next loop, if I send the A, I should get O. And then in the next loop, if I send the M, I should get I. I mean, that would mean there is no loss, perfect loss. So that's what he does. He's saying, I'll take the first 3 characters, the output will be the next 3 characters, then I'll jump the 6th character and then go to the outputs.
Yeah, this is where he starts talking about teacher forcing.
Teacher forcing, he's comes as a language model.
Because if this were not G, but instead if this were Q,
yeah,
he's not going to feed Q into here. He's going to feed G into here because G was the right answer.
Right answer, yeah. That's where you do the teacher forcing to make it learn better. Because because initially
if you put Q in there, then it's
not learning.
Yeah.
Yeah. That's where you get to the teacher forcing thing, which he talks about in his language model. Before this, he builds the language model completely out of FastAI. I mean, this is one where he builds it from scratch. And this is where he says, I'm going to feed this.
So does he do teacher forcing here? Or
no, he doesn't do the teacher forcing here. He doesn't do the teacher forcing. He talks about it during the language model he builds, but that's all completely so opaque because I couldn't see. I mean, it's all FastAI code. He just says 3 lines or 4 lines of code, and then he adds some teacher forcing to it and stuff. You get the idea of teacher forcing, as you say. He talks about that teacher forcing. But that's what he would do in teacher forcing in the language model. I mean, he says, where it's not a character by character, it's more as a word token, tokenized words. And he does the teacher forcing there. Yeah. But he says, this is more efficient. Now I'm only feeding IAM once to the net. I'm not feeding IAM and then AMG and then IMGO again.
And does the nn.rnn or nn.gru, does it give you all the intermediaries?
All the intermediary, yes. That's what he says. He gives you all the intermediaries.
Not just
the last one. It gives you all the intermediaries. When you look at this output here, it's actually not one, it's an array of outputs. So it'll be an 8-array output. And that's what he goes and flattens that out here. He's saying dim, self yellow out of that output, dim equal to -1, and then he says the flattens that out and the vocabulary size. Because he wants to compare it against the whole thing.
Was somebody supposed to come into the room? Because that was like 40 minutes ago and they never came.
Yeah, somebody was saying, and then the Honey Dripper conference room, and he said a thing, Boyam. Oh, okay.
Yeah.
But he must be, if he's asking which conference room. I thought he was in the building here. So yeah, it remembers. If you look at this RNN and the GRU there, it talks. I think that's. It took me some time to understand what he was trying to do there.
Did you train it up and get it to output Shakespeare or something?
No, this one doesn't output Shakespeare. All it does is I did enough so that, it'll only just get something like going out from there. Where did I? Okay, this didn't even have, I didn't even output stuff. I thought I outputted stuff from this, maybe another sheet or something. I trained it.
And this is like a 1-layer RNN, but they have.
Oh, yeah. This is just a 1-layer RNN. And I don't know where, I was just looking at probably just the loss function and stuff. But this will all it'll do is you can give it a starting point, some 3 words or whatever, 7 words, and then ask it to go through loop, and it'll give you some text basically, which is what he does here. I thought, well, it was actually lesson, though I have named it as lesson 5, I think. What did he do? But that was an important concept where he says, I'll do a multi output rather than a single output, and then use the output from there and then compare it rather than, no, that was the movie lens thing. Again, named it wrong. This should have been 6, I think so. Is this the one? Yeah. The multi-output model. He talks about the multi-output model.
So this is all in lesson 6 or
lesson 6 is not 7. It's lesson 6. It's lesson 6. Where the multi-output model, he calls about, hey, this is 40. This is a batch here, but then this 41, 33, 2, and all that stuff. He's got 1, 2, 3, 4, 5, 6, 7, 8 here going on. And then he says, this 42, 130, this 42, 138, 44 is the next set of outputs from that. That's a set of outputs from this.
Guys,
Oh, hey.
just decided to drop by.
Ah, okay.
I'm Boyan.
Hey,
From the meetup.
Yeah.
Nice to meet you.
Yeah.
David.
Eric.
Yeah, this is the next word.
Oh,
This is the next word.
So
Yeah, that's what I was gonna say. I wanted just to kind of drop by and see, how far ahead you are, because I haven't started
I just looking through the lectures online. I finished the Coursera course before, so it's kind of a, I don't need to start from really the basics, but at the same time, I'm not, I don't have that much from the class.
Okay. Yeah, I think we're going through lesson 6.
6,
And
yeah.
there's what, 8 in the first part, and then another 8 in the next part.
Yeah.
But we are constantly going back and rediscovering parts that we didn't understand from the first 5.
I see.
So
Yeah. That stage, I just started setting up paper-space, but I'm not sure if anybody else is using anything else. Everybody's using paper-space.
I have a machine in my basement, and I think Narayana has something similar.
Something similar in the basement, yeah.
Okay.
I have a
Everyone's AWS,
Oh,
but you have to remember to turn it off.
yeah, that's the big pain. I don't use it.
We've been using Colab a little
Yeah.
bit for
Yeah.
like demos and stuff.
The lab,
Okay.
cloud stuff, not,
The GCP?
Yeah.
Yeah, that's, I mean, I've made accounts. I have an AWS account, but, I kind of ran out of food credits there. But I made a GCP account, which still has some credits. So I was trying to see if I can use that. But I did set up paper-space too. So I was like, okay, let's see, just to get started, and then maybe I'll move to.
I've had trouble with paper-space connecting, but like every time I hit power or connect, it just keeps spinning for a long time. I've reached out to them, but
I had some issues with paperspace too.
it's what?
I had some issues with paperspace
Yeah.
too, but I think that's when I got overloaded because it was right when the Fast AI course came out.
Oh.
I used paperspace, but I think everybody tried to use it at once and they weren't really ready for it. I don't know what it's like now, but I'm sure they've figured out a way to.
Yeah, in fact, they're not doing this. In fact, what I'm looking at is they're not. This is the if I am going thing. I mean, what they're doing is sliding. If I am going this, if you're taking the three words, 3 characters, the output is A, M, G. That's the Y, because he's trying to predict the next character, next character. So because when you send IN, it should actually predict not G, it should predict A, because it can only predict what the next character is.
Sure.
And then this one is going to predict M, because if I send A, it should predict M.
Yeah, it's a single character
Yeah,
at a time.
at a time. I mean, if I send the M, it should predict G. But it has a 3 memory thing, basically. So he slides, I mean, he takes IAM and then he slides one and says that's what it's going to predict. Then after that, he gets, now the next set will be he skips 3 and then goes to the GUI and then says what should Y be. That's what he's doing. Because if you see, this is 42, 40, 42, 29, 30, 25. Okay, here you are. The output is 42 just by sliding 1. This is 42, 29, 30, see 42, 29, 30, 25, 27, 29, 1, 1.
Yeah.
That's your output, which is slid by 1. And then the same thing with the next one, the 143, which is completely, you skipped 8, and then you've taken the next 8 characters, and then you're saying, okay, my output will be sliding by 1 on that, and then there'll be 1, 43, 45, 40, 40, 39, 43, and then the 33 from the next one. So. Which that was pretty, because initially I thought, I mean, that was a pretty cool idea. Hey, I'm going to have a multi-output rather than a single character output. And he does the same thing. He does this. He talks about this identity initialization. And he goes in and copies an identity matrix to this RNN weight of the hidden layers. So I didn't quite get why he was doing that, but he said that's something he's trying to initialize that in some fashion. The identity stuff in there. And he said that's from a paper that they suggested doing that to speed up conversion. So I have to go back and see that. And then here's where, I mean, you're talking about the stateful model. I don't think this is the multi-output model. It's just a multi-output, yeah. Loss of max. So what is not stateful there? It's getting stateful there.
I think it's interesting that he takes.
Oh, the
top-down
output
approach.
H. Huh?
I think it's interesting that he takes this top-down approach for CNNs and for the embeddings and the other stuff, and then he gets into the details, but he does the opposite for RNNs. Like he doesn't give you here's the 3 lines to build state-of-the-art RNN on language.
No, he does. The language model, he does. He starts off with that 3-line thing. This is going into the in-depth. This is lesson 6. Lesson 3 or something, he goes to a language model where it's just the top-down model. Yeah.
Forgot. Okay.
Yeah. Yeah.
Okay.
Is this lesson 6 or lesson 7?
Lesson 6. I have to rename it. This is lesson 6.
Sorry.
Yeah.
And it's actually the notebook that's, the Jeremy's notebook.
Yeah, this is just Jeremy's notebook.
Okay.
This the only thing, yeah, as you said, this is why he's doing the stateful here, because he's not here, this was not stateful, as you said, because every pass he's making it 0, and then in the stateful he's not. He's just detaching that, the repackage. We saw that. I mean, he goes through that, and then the RNN loop, what is it? He's just showing what that does. What is the RNN does in PyTorch? He's saying that's what it's doing. This loop is this tan edge of this versus this thing. That's what it's doing. He's just showing how do I get that loop. This is what, in fact, is looping inside PyTorch. And then he starts with he's doing that loop here inside. I mean, append, and he's doing the loop of the embedding of that and doing that. So he's just showing how do you loop through on the RNN, which is being done inside PyTorch. And then he goes into the GRU and he gets and then he shows what is happening in the PyTorch source code on the GRU. So he's talking about where these hyperparameters are defined and the gates are defined, and he does explain that. I mean, I get it when I see it, and then I forget it. I mean, I'm not at the reset gate and the input gate, but he shows what is happening there. I mean, the sigmoid, and what is, he's saying, what does a chunk do? It does some specific thing there, a chunk. IR, HR, HA. I mean, you can go through his video. He talks about what is actually, from a very conceptual point of view, what is it doing? And then he keeps getting lower and lower. And then he finally gets into an LSTM, which he says, yeah, LSTM, he uses that. So it's the same. I mean, once he does that, he's just doing the same thing over and over again with other things there. With the GRU, and then he's gone into the LSTM, and this one, there is 2 self.h is 0 of NL, and then NL. This in fact has become, see that this was only vtorch of zeros, 1 and batch size, and then the hidden. But with an LSTM, he's actually having to put a tuple of,
He does 2 of them.
2 of them. I don't know why. For an LSTM, he's having to do 2 of them. And then it has a dropout too on that. And I have to check. I mean, what does the LSTM do that it needs? It must have a hidden thing that comes out with two LSTM. Okay. See, he also does this. See, here too. Hidden status is a tuple of two tensors there. Yeah, this is all getting into the so.
Yeah, I don't understand why.
I don't understand why SVM example from the docs. Okay. Hmm. Yeah, the output for is the output for all the hidden nodes on the final layer. Hidden size, the number of LSTM blocks per layer. Okay. Number of hidden layers, yeah. Hmm.
Oh, it's bi-directional LSTM. And there would be two hidden states, one for the forward direction, one for the
Back direction, there'll be hidden size times number of direction. You didn't initialize that. Size equal to hidden size. I can't imagine he did a bidirectional stuff there. And all he said was number of factors and number of hidden, which is the 512. He used a 512 hidden size, and then NL. What is the NL?
number of layers.
Yeah, number of
What
layers.
is the value? Yeah.
Hmm.
2.
2. So that's why. So he has a 2 LSTM layer, which means it goes through. This must be something there. 2 layers. So what's the PyTorch?
So each of the recurrent neural networks can be unrolled in time, right? So this is back propagation through time times 4, right? So
Yeah.
you have an input that comes in, and that creates the hidden state in between. And then you have in 2, in 3. And if you want to have multiple layers of recurrent
See.
neural network,
Yeah,
you
it's a
still think of
multi.
it as a roll like this, then you have to do it like this.
Oh.
Well, guess this would be.
Okay. Okay. Okay.
So there's really two sort of hidden states for a two-layer.
But what does it
Recurrent
mean?
neural
But then what happens to, this is independent of this?
Yeah,
So.
yeah,
what's
yeah.
the
So
use
this would be sub two.
Yeah, I know. But what is it doing then?
Right. This would be.
What do you get out of this if it's
This would
just?
be the same as.
Oh. Is
I
it
guess-
H1?
It
Yeah.
would be like H1, H1. Where the last one is the time.
Yeah,
step.
LSTM, it says applies a multi-layer long short-term memory RNN to an input sequence.
But it would be the same if you had a multi-layer without the LSTM. It would just be just.
Number of recurrent layers, example setting number of layers would mean stacking two LSTM together to form a stacked LSTM with the second LSTM, taking in outputs of the first LSTM and computing the final result. So that's what, okay, so the taking in outputs of the first LSTM and computing the final results.
Trying to do it with subscription.
Yeah, subscription, yeah, okay. So,
So you have
It's-
your input.
yeah,
This
and so it's still going through that first, but then the output of that is coming through another layer here. Yeah,
And so
and then-
the outputs that you get from this
yeah,
would be the H11, 12, 13 as a
Yeah.
tuple.
yeah.
Followed by the H21. So that's your hidden state when you're done.
Hmm. That's why it's a tuple there. There's two hidden,
Because there's two layers.
two layers. So
And then at the
ultimately, at the end, there is an output there and an output from that too. So is there an output?
Um, and I guess this is the same as that one.
For each T. For each T. And unless you go through this. Super LSTM.
But I guess that's stacked instead of like sequential, because you could have instead of putting them stacked, you could have put them sequentially.
Hmm. Yeah.
Yeah, this is pretty common.
Huh?
That's pretty common.
Just stack them.
Stack them like this. Yeah.
I was just looking at, one of the exercises was using the same, in the Coursera course was using the same, like two LSTMs in the same construction.
Construction like this. Okay.
So, we have,
Oh.
yeah.
This is the Coursera cases of Andrew Ng. Andrew Ng. Oh yeah. Okay.
Yeah.
Okay. Yeah, this must have, I mean, he uses that. I mean, then again, you're now using deeper, I mean, yeah, you're sort of, if you're using, initially we used 4, now you've doubled that with the stack layer. And obviously they say you can stack it even more, but it must be able to remember better through this. So, I mean, finally he gets down to, he does all the cosine annealing and he tries a few things, and then he finally gets into point 1.13 is when he says get next for those, and he gets E, but then he says, okay, I want to keep looping through that and get the E and take that and get me other text, and yeah, he gets something, yeah, which is supposed to be in the neat style.
Contradicting? Contradicting?
Yeah. But he says, okay, if you had stopped at, I mean, this is what you'll get at 1.15. If you stopped at 1.25 or something, you'll just get gibberish. I mean, just going from 1.25 to a loss 1.15, you start getting at least some sensible words out of this.
Yeah, for me, I remember reading the Andrew Karpathy's book.
Oh, yeah, yeah. Yeah, the recurrent network thing. That's on a word base. I don't think that's a character thing.
No,
it was a character RNN. Oh, okay. Yeah. Okay.
And then he showed how it would work on
Shakespeare and yeah.
And XML and
oh yeah,
C++
the latex and
and
stuff,
LaTeX
and yeah. I don't know, at that time, did he use an LSTM or what he used? I don't know.
Yeah, I think he was using LSTM.
Okay.
And then he like went on and showed.
But what is is it an LSTM? Does it have all the gates and stuff like a GRU, or is it just 2-layer thing?
I think it has more gates than a GRU. GRU
Okay.
is just one gate, but then there's like two different gates along.
Oh yeah. See here, he has that IET, FT, GT, OT, all that stuff is there, yeah. So yeah, or the input for get cell and output gates and sigmas and all that. So he doesn't show somehow. This is not where all the code is being shown what they do. Because what does this LSTM do here? LSTM cell. That's what probably does this. Does all the computation probably. Yeah, that's where all the forward and all that stuff is there. It's the cell thing.
So Jeremy doesn't talk about applying RNNs or LSTMs to financial or otherwise time series data.
No.
Other people have talked about it. And like, what's that flamboyant guy on YouTube?
Oh, the Suraj.
Yeah. He talks about forecasting Bitcoin.
Yeah, I think I just saw his
Stuff.
stuff. I think there's a lot of discussion on Quora.
Project. What's that? Yeah.
In there to really process through.
Yeah, no, it's a mixed bag too, because I know he just rips off other people's stuff. I found like the original sources of some of his things, like he did a video on variational autoencoders. and then didn't say where it came from. Then I found like the blog that it actually came from. It was like the exact code, ripped off like line for line. So like that sucks, but it is true that there's like a lot more to it because where he's like pulling his information from is like real sources. Right. So that's why it seems denser than it is or whatever. Like,
You're talking about a project?
well, I don't know. I thought maybe
Yeah,
more than just
yeah. This is just,
notebooks.
oh yeah.
Like,
I'd be interested, because I think that would.
Yeah.
Work on that too, so.
Oh yeah, I mean, the same way we tried the other one,
The Dollar Street.
the Dollar
Yeah.
Street, and so we can talk about if you wanna try some things and.
Like, just financially, or?
I don't know. Or weather or
Yeah.
I don't know. At least you know the weather is not totally random. Whereas I feel like a lot of the times, like all the financial predictions, like you could just be trying to predict a random
Yeah.
process.
Yeah.
And nobody can predict coin flips. Like I don't care how good your machine learning is. It's a random process.
Yeah.
But it would be really cool to have a toy.
I think that'll help
Project.
solidify some of this stuff too.
Oh yeah. Yeah.
Because you learn by doing, so yeah.
Oh yeah.
Is there? I'm sure there's Kaggle data.
RNN use cases or something. I don't know.
Sequential.
Historical weather data for 2012 to 2017 on Kaggle.
Real estate too.
Some other Coursera course, I suppose. There's another practical use cases of RNNs.
I was personally upset about how bad the weather apps are on my iPhone. And I was just like, can they do better than this? Like, why are these things so long to load the data? Like, I'm sitting there waiting for it to load. I could probably write something and do this faster. And it's almost always like so wrong too, like even just like one day out.
I mean, a lot of the weather apps are full of ads. I had the weather bug, and I just uninstalled it. So,
Yeah. Well, it used to
Too
be
much
the
of
Weather
that.
Underground was like a good one.
yeah.
And then they were bought by, I don't know, the main one, not.
They're about that, like the Weather Channel.
Yeah, the Weather Channel. And then it just went to crap. Like, they just must have just thrown away their old models. Or whatever. It'd be interesting to see how good we could predict hourly weather for St. Louis or something.
Yeah, I found a ton of core links for RNNs and time series. I'm gonna read that tonight and see
Oh,
people
some
discussing.
applications.
Yeah, applications and people discussing different models, and I'll be there for time series. But
I mean, a lot of this could be like, I don't know, customer behavior, based on what you did before, if you're gonna like buy something. Things like that. Like data for previous decisions that, drive the next decision. That's what he wants for work.
yeah,
So it would be,
Yeah.
that's.
I mean, the thing that
And
you would want to do though is somehow incorporate, like they did for the Rossman data, like when holidays are and other like important dates, because that really drives consumer behavior. Like if you know it's the day before 4th of July, like you're gonna get a spike of sales and certain things. So,
With traffic,
so the RNN like couldn't model that.
web traffic
untitled.
on
Web
Kaggle.
traffic, okay.
What does it say? Web traffic time series forecasting. That's
Was
what
that an
I'm
actual
talking-
Kaggle competition or was
Yeah,
it?
I think so. Forecasting
Okay.
future traffic to Wikipedia pages.
And they used
Okay,
an
so
RNN.
that's- Well, I'm sure some people did, I don't know.
Some people did.
But maybe somebody wrote about the winning
Yeah.
algorithm. The nice thing about the competitions is you actually get a lot of people
Oh, yeah.
to compete against, and so you
Yeah.
know, like, what is a good model? I don't even know. Like, if you just pick a toy data set, you're like,
yeah.
that seems pretty good.
Yeah.
You don't know how good is it?
Exactly. I mean, the nice thing about Kaggle is that the data sets are clean, right? So you don't have to spend like
Oh, yeah.
80% of your time setting up your data set and cleaning up with like real data.
Yeah.
I think this guy used the OS team web traffic.
Mm-hmm.
Yes.
He used an RNN,
Yeah.
LSTM. Okay.
Yeah.
What kind of score did he get? Compared to the, yeah, it's like usually I see.
Oh, it's only 8 months old.
Yeah.
It's not a very old
Yeah.
competition.
That's a new one?
The web traffic is only 8 months old.
Here's the problem. Is there a Kaggle time series? These Erasmus cells and solar energy forecasting. That's a core.
Well, Rossman was technically time series. But
It's time series.
Yeah.
That was a Jeremy's example.
Yeah, Jeremy's example,
Yeah, this is Jeremy's example.
Yeah.
where he uses just
But he
embeddings
doesn't
and
use
stuff.
RNNs for it. He just
No, he just used a normal deep learning thing with embeddings and just linear layers and stuff. Yeah.
That was the tabular or whatever.
Huh?
Columnar data example.
Yeah, columnar data example.
Yeah.
Wind forecasting. Tourism forecasting.
So actually, I have a quick question. When I set up Paperspace, they say, well, if you want to use the fast AI public template, you gotta wait until we validate something like that. Did you guys get all that?
Really?
I tried to, just click on that and say, oh, tell us what we're gonna use this for. Because,
Yeah.
And then, next to the thing was like, we'll send you an email when it's available. So, okay. I gotta wait.
Really?
Yeah, I
You still-
remember I had to go through.
Okay.
But when did you do this?
I just did it today. I was just setting
Just
up
today?
Paperspace, yeah.
Okay.
So I just don't know if it's gonna be like a day or.
No,
days.
Paperspace takes a day, I think. Isn't Paperspace is where you set up your own machine and you start your own machine and stuff? Because there is another place where you don't start your own machine, it's already gets started. What is that site? That's one of his students set it up. It is not Paperspace, where the Jupyter notebook comes out automatically. I mean, you just.
Paperspace is working on a thing like that as well.
Oh,
Just a web UI that is just a Jupyter notebook.
Jupyter
You
notebook.
could also
This,
use Kaggle kernels too.
Okay.
But there too, like you're on a K80 and
Yeah.
you don't know if you're going to get it or not, depending on their traffic.
Mm-hmm.
And you can't install any like external libraries if you use a GPU on the Kaggle
Okay.
kernels.
This is
But
the
they have fast AI.
machine learning mastery.
oh,
Yes,
okay.
But they have the.
Ton of?
Like a fast AI.
Oh,
environment.
okay.
He tries to sell his book, so
The
maybe.
Oh, I'm Jason Brownlee. I've seen this guy before, right? Probably.
They're basically just.
Yeah, I think
Like the book, right?
Paperspace has,
No, the fast AI.
I'm
What they
curious
use
to try.
is the version set.
But it is in,
Smoke arrows,
carrots.
torch, all that.
Yeah,
yeah. which
Probably.
place, though? Like, I think you can get it everywhere. You
No,
can
no,
get it everywhere.
I'm just saying, if I want to set up my own environment.
Yeah, so here's, but if you
know
go to
which
the top
version
version,
I would use it like a
Yeah,
fast
see the
AI
skip
has
the
some
academic, just the
kind of
results and
spec
stuff.
somewhere, or-
this is the book I was.
Yeah, this is the
AI
book.
is installed.
Yeah.
Okay.
So Python,
But they wouldn't install the test. Or
it would install PyTorch, which
Oh,
is also
okay.
installed.
Okay, I got it. Okay, I got it. So I can just go and install.
Yeah, I think you can just pip install fast AI.
Okay.
Yeah.
That's it. Yeah, that's kind of my next route. Stay up.
Yeah, you in Paperspace, you gotta be careful that you shut it down and stuff.
That's always.
Yeah.
Cloud computing.
Did you put like a hour timer or something, so if you don't music for now, it shuts down automatically. They have like an option for that.
Yeah, that's nice. Yeah, I mean, I'm setting up Paperspace. I'll probably wait until I get the confirmation, but I might just set up a GCP as well, as a parallel.
Yeah, AWS made you wait in the past for their more powerful GPUs, like P2 and above, but I think now you can get a P2, just not a P3 without like some email approval or whatever.
I see. Okay.
They're trying to stop the automatic like, Bitcoin miners from just using it.
Yeah.
Yeah. And you definitely can't use your free credits to do like the big GPUs.
Yeah. I see. All right, we'll give it a try.
I mean, let's think about some applications and we can maybe come to next week and discuss that. And let's research some applications.
Well, the really nice thing about the Kaggle data sets, like making a kernel on Kaggle, is all the data is already downloaded for you.
Oh, yeah. Yeah.
Like, like the VM that they give you already has it mounted and everything. You tell it what data set you want to use, it's just there.
Because our goal isn't to try to get the data, work on the data, it's to learn the model. So
yeah,
if we get the data there.
But you won't be able to use sconce there. You will be able to use FastAI there. I think.
Yeah. Have they downloaded? Is it available?
What's that?
Can't you use sconce?
Well, for their GPU support is new, and so they have Docker containers where you can like put in your own, but not for GPU support. For GPU support, you only get their like exact canned like container.
What
There's
they have
only one image that they have
And you
that
can't
has
install
GPU
anything
support.
else on top of that.
Can't install anything on top of it. So you get what they have, but I think they have FastAI. I haven't confirmed that. I haven't actually checked, but I saw that there was a forum posting where Jeremy was like asking for them to install it. He used to work there, so like he was president of Kaggle for a while. So I assume that there's still people there that would be like, "Oh yeah, Jeremy."
Oh yeah,
let's
Jeremy.
go around the show."
Jeremy was
president
of Kaggle for a while.
Yeah.
This would be, I mean, music composition. They say applications of this. We can look at that. Music composition. That'll be cool. Yeah, the words. I mean, we always see the language and stuff. I don't know how the music. I haven't seen an article about music composition on it. But how do you? I mean, how do you take music in the sense that, I mean, how do you read? I mean, do you read the symbols and then do you codify the symbols, or?
It's a spectrogram. It's a spectrogram. You convert basically your file into like frequencies and times.
Oh.
It's like a spectrogram basically.
Okay.
There's one exercise of that, and I'm exposed.
So he does a assignment on that.
Music generation.
Yeah. Music generation.
Depends on how much you work on it.
Oh, okay.
It's five modules, qualified courses.
I would like to do that assignment. Okay, he has a.
That costs money.
Yeah.
No, you can audit it. You can audit it. You can audit it for free.
Oh yeah, I mean, I think the one reason is that our company basically just set up an account. They say, whoever we had a cohort essentially that was working on it, so that's kind of that's how I did it.
Oh, so if he has music composition, I would like to know what he does. I mean, is he taking the music book and converting it, or he's listening to music?
No, I think they take like a MP3 recording.
Okay.
It's a pretty different format.
Okay.
And just reading this, I mean, there's just converting into like a matrix essentially.
Okay.
And then and basically using this to train to generate your own like a jazz piece.
Oh, okay.
Yeah, and actually, I mean, I have the notebook. If you want, I can show you next time.
Okay. Yeah, that'll be cool.
I'm interested.
Sure.
Yeah.
I've heard of people just doing it on MIDI files, but I haven't heard.
Yeah, MIDI. Yeah, that's right. I mean, you can convert
MIDI
MP3 MIDI.
Okay.
Doesn't matter what format it is, but yeah, usually you work with MIDI. But it's they describe it as convert it to spectrogram, and then it's like a matrix, right? So you feed that into your network, and and say I want to generate a piece, and you generate like I don't know, like a 30 seconds or something like that, 1 minute. Yeah.
And I don't know a whole lot about music stuff. I thought MIDI file though was like, it already was like a set of instruments and then the keys they were playing for duration or whatever. Something like
Yeah, but I mean, generally music that's what it is, like different frequencies and durations. I mean, basically each note is a certain frequency and lasts that long, and that's the music essentially. So you can convert any music or any sound essentially. I mean, actually there was another exercise which was like a training to recognize speech.
Yeah.
With like a noise, car noise behind. So basically you take like several, word, they call it utterances and put on top, some background noise and use that and see, okay, just train the model and then say, okay, I can recognize with this kind of accuracy. But yeah, I mean, it was it was kind of interesting.
Because fast AI doesn't do anything on speech and stuff.
No,
They don't go. He's more on the image, and the image is quite a big portion of this. Even in the deep learning course too, the bounding boxes, and then the style transfers, and then the generation.
Almost original applications too.
Yeah. He goes a lot deeper into the image problems than any other problem. I mean, he does do the sequence-to-sequence language translation.
Right.
Does that, but all other lessons are on the images things.
Stanford had a deep learning and NLP class. Are there examples in there that can be used?
Okay.
Can you Google search for Stanford and deep learning? Stanford, deep learning, and NLP.
Yeah.
Of course, maybe.
Deep learning. Okay.
Something there that's an example that can be used to sort of. Take a look at the old projects and see if there's something to.
What is the previous year's project reports? Yes, 2016 reports.
Deep learning for music.
Yeah, deep learning for music. Yeah. Delegation and congressional bills. Okay. Pretty cool. Yeah, the MIDI data, you're talking about MIDI files. Muse data, yeah. A corpus for Muse data because Bob was comparatively most. Okay. Yeah, read this and get some idea of, thing and how they do it. And
Yeah, I think we're using RNN here, right? Search for RNN. Here.
I didn't see RNN referred to here.
Or LSTM, I don't know.
Okay. Particular, there has been a lot of work based of recurrent neural networks with a restricted Boltzmann machine and other. Our approach, however, is to perform end-to-end learning and generation with deep neural networks alone. They don't talk about you used a 2-layered LSTM RNN to produce a character level model to predict the next node in a sequence.
There we go.
Yeah. Which would be very, very similar to similar to this character prediction. And
yeah, just about it. I think it's the exercise called improvise adjust solo with an LSTM network. And I could, I can play use like the training example, and it's very simple and small. This is the training example. Just like jazz.
Yeah.
Yeah, it's like 7 minutes. Actually.
Okay.
basically that's the result. Of the network. It sounds like jazz, close enough. Right?
Close, but it isn't close enough to the original music.
No, yeah, I didn't play the whole piece.
Huh?
I didn't play the whole piece of the original. It's like 7 minutes.
Oh, okay. So there is some. Okay.
Yeah, there's probably some piano.
Yeah.
Somewhere in there.
Solo.
Somewhere in there.
But
Okay.
yeah, it's kind of it was fun exercise. See how it works. Essentially. I don't know. Again, I'm sure everyone has it next time.
Yeah.
So web traffic time series, 5th place guy, I just read his discussion post about what his architecture was. It was not deep learning at all. It was just a polynomial regression.
Mm.
He even says at the end, and of course neural nets, I should learn more about those. But I mean, he got 5th place. So.
Yeah.
I guess a whole bunch of people who were doing neural nets did a lot worse. So,
Sometimes simpler, sir. Sometimes easier.
Right. Yeah, I mean, some
cool.
ensemble models probably do better than the deep learning models sometimes. But on type of data. Especially if you don't have
so what do we want to do for next week, I guess?
Yeah, we did. I'd be interested in that, just to learn RNN, even if it doesn't perform like.
For what?
Well, like
what-
the
what?
music or something, we'll have to.
Whichever has data and.
Like, I think for weather, it'd be kind of cool if we actually come up with something and we could just throw up like a small instance on AWS or something that we could actually like use.
You mean
That'd be
like
cool.
deploy it?
Yeah, like on a $1 a month instance. Like it wouldn't be on a GPU, obviously, but once the model is trained, deployed.
Oh, weather forecasting.
Yeah, actually, it
But
might be more expensive than that.
yeah, it'll be more expensive than $1 a month. But
Yeah,
There's micro instances on it.
it could. I don't know what. I mean,
Depending on how big the model is.
model is, yeah.
I mean, it was a while back before deep learning was so popular that there was like a team in like Harvard National Lab running weather forecasts. And they were running at the biggest supercomputer at that time because they were getting so many like radar input.
Yeah, but they go down to like the square,
pretty.
like 100-foot resolution, and they're like running like thousands of parameters. If you're just doing like 1 hour resolution on like 12 cities.
Yeah. If you need something more, not exactly. Yeah, but I think they were trying to get a super accurate within a week. And they said, well, our model runs like for 3 days and we have to, that was a challenge, right? So I was like, okay, you run for a long time.
Yeah.
Trying to predict 7 days out.
No, I watched a video that was really interesting. One of the guys who sets up and like designs the supercomputers for the National Science Foundation and the NIH. And he was talking about how there's a big shift that has been happening where the